I am Professor Stephen Hawking and I think GCSE Physics Explained YouTube channel is great.
Resistance. Here are the aims of the video. Pause the video and have a look. We use resistors to control the size of the electric current in a circuit. Electric current is the flow of charged particles. In solids, the charged particles that flow are called electrons. Free electrons. If there's not much resistance in a circuit, then the electrons will flow fast and there'll be a large current. If there's a big resistance in a circuit, the electrons will flow slowly and there'll be a small current. So what is resistance? Well, basically, it's when free electrons collide with ions in the solid material as the electrons flow through it. The more collisions there are, the bigger the resistance is and the smaller the current will be for a given voltage. If you look closely at the animation, you'll see the collisions taking place. The collisions cause friction, and friction creates heat. So materials can often heat up when an electric current flows through them. Some electric devices are designed to have large resistances so they heat up on purpose and even get so hot they glow and give off light, such as heaters and bulbs. The analogy I use with my students is that electrons flowing through a component is a bit like when you walk down a crowded corridor. If you don't collide with many people, you flow fast down the corridor. That's like a big current. But if you collide into lots of people, then you'll only flow slowly. That's like a small current. Around 1825, a man called George Ohm discovered a relationship between voltage, current and resistance. He described voltage as being like electrical push. The bigger the voltage, the bigger the push on the electrons, so the bigger the current. This is Ohm's law. Voltage equals current times by resistance. Voltage is often called potential difference. V equals IR. To help you memorise this equation, because you won't be given it in the exam, remember this. Ohm's law is a very important rule. V equals IR. Voltage is measured in volts, current is measured in amps, and resistance is measured in ohms. Here's the magic triangle to show you how the equation rearranges so you can work out current and resistance as well. Ohm's law in words states that the voltage or potential difference across a conductor is directly proportional to the current flowing through it, provided all physical conditions such as temperature remains constant. Any conductor that obeys Ohm's law gets called an ohmic conductor. Examples of ohmic conductors are copper and constantan. To measure the resistance of a component, place an ammeter in series with it to measure the current going through it, and place a voltmeter in parallel across the component to measure the voltage across it. Once you've measured the voltage and current, divide the voltage by the current to work out the resistance. Here's an example. To learn more about ammeters and voltmeters, I'll place cards at the end of this video. We use resistance to control the size of the electric current in a circuit. So if you've got a variable resistor, then you can easily vary the resistance in a circuit and hence vary the current. To make the current bigger without changing the resistance, you can use a larger battery. You could do the same to make the current smaller by simply using a smaller battery. Resistors in series. If resistors are placed in series with each other, the total resistance is the sum of the resistors. In other words, just add the resistors together. For example, 3 ohms plus 5 ohms equals 8 ohms. The resistance increases because all the electrons have to go through both resistors so there's more ions to get past, so there's more collisions. Resistors in parallel. If you place resistors in parallel with each other, the total resistance is actually decreased because there are now extra paths for the current to travel down. For example, a 10 ohm resistor and a 7 ohm resistor placed in parallel will have an overall resistance less than the smallest resistor. The total resistance in this case is 4 ohms, but at GCSE level you don't need to calculate the resistance, so I'm not showing you how I did it. That's A-level physics. The way to visualise resistors in parallel is to imagine you are trying to get into a football stadium and there's only one gate. The flow of people into the stadium would be slow. Now, imagine you opened up another gate. The people can flow into the stadium faster. Well, that's like the more parallel branches there are, the more paths there are for the electrons to flow down, which makes the current bigger and the resistance smaller for a given voltage. You can look at it mathematically if that helps, like I'm showing you here. For the same size voltage, if the current gets bigger, that means the resistance must have got smaller. Here's a summary of what you've learned that will help you in your tests and exams. Pause the video and have a look.
I thought that was great, Mr. Obee.
Well, I hope that video was useful and that the animations helped you understand. Subscribe to my channel if you want to learn more. Bang that bell all over the place. Smash the like button while you're at it. And apart from that, work hard, be nice, and bye for now.